Today we are going to solve the problem 2.1 of Griffith third edition. This problem contains three theorems. We have to prove all the three. The problem 2.1 is prove the following three theorems. First one is for normalizable solutions, the separation constant E must be real. They have given hint that is we can say E as E naught plus I comma. That is, we are separating E into real part E naught and imaginary part I comma. Here, with E naught and gamma real. Remember that gamma is real, but we have introduced a complex number I. So that if equation 1.2 is hold for all t, gamma must be 0. So we have taken equation 2.7, that is psi of x and t is equal to psi of x e power minus I e t over h cross. So this is the expression. So I have rewritten this. We have replaced e by e naught plus I comma as given in the problem. So I have replaced e, that is e power minus I. E I replaced as e naught plus I comma t over h cross. So now I am separating this. So psi of x e power minus I e naught t over h cross e power this I into I squared, you will get um, minus I. Here already there is minus. Because of that minus only here you got minus. So minus of minus will become plus e power gamma t over h cross. So if you take modulus psi squared, then this will be modulus psi of x squared, and this will become 1, because if you take complex conjugate of it and multiply, you will get 1, because one is plus exponential plus and the other one is exponential minus. If you multiply both, you will get 1. Then this term left, e power 2 gamma t over h cross. Now for normalization condition, the integral between minus infinite to plus infinite modulus I squared dx must be 1. So this is possible if you want to prove this for all t cannot be 0, but only possibility is this gamma will be constant. So we have proved that gamma must be 0. For a normalizable state, the probability must be finite, and by continuity equation is constant for all t. This is possible only, as I said, gamma must be equal to 0, and E is a group of real part of it. Then we will move on to next theorem. The next theorem is the time independent wave function psi of x can always be taken to be real, unlike a psi of x and t, which is necessarily complex. This does not mean that every solution to the time independent Schrödinger equation is real. What it say is that if you have got one that is not, it can always be expressed as linear combination of the solution with the same energy that are. So you might as well stick to size that are real. Hint, if psi of x satisfies equation 2.5 for the given E, so too thus its complex conjugate, and hence also the real linear combination psi plus psi star and I psi minus psi star. So the solution is very simple. We can argue with the conceptual one and we can prove it. If psi of x satisfies the time independent Schrödinger equation, that is H psi is equal to E psi, then its complex conjugate is also satisfied. H psi star is equal to E psi star. So both psi of x and psi star of x valid solutions with same energy E and E. Therefore, their real and imaginary parts also solution. Of course, their linear combination also. So the real part is psi plus psi star, and the imaginary part is psi minus psi star. Now the third theorem is if v of x is even function, that is v of minus x is equal to v of x, then psi of x can always taken to be either even or odd. Hint, if psi of x satisfies the equation 2.5, which is a Schrödinger equation, for a given E, so too thus psi of minus x, and hence also even and odd linear combination, that is psi of x plus or minus psi of minus x. So let us take the Schrödinger equation for positive wave function, that is minus h cross squared over 2m t2 over tx2 psi of x plus v of x. We know v of x is real. Psi of x, which is equal to e psi of x. It gives the eigenvalue e. Similarly, if you replace this psi of minus x here, we know v of minus x is equal to v of x is even. So we are writing v of x as it is. So psi of minus x, which is equal to e psi of minus x. That means psi of x is a solution for the Schrödinger wave equation with energy E. Same thing, psi of minus x also the solution for the same Schrödinger equation with the same energy E. So naturally, their linear combination also the solution of this Schrödinger equation. That is psi plus or minus is equal to psi of x plus or minus psi of minus x. We can always choose the solution to be even or odd when the potential is even. If you find this lecture is helpful, kindly like it and subscribe it. Also join to my channel for the growth of my channel. Thank you very much for watching my videos continuously and supporting me. Thank you very much.